Good day and welcome to yet another episode of the Grade 12 Geography Cap series. I'd like to thank you for tuning in again. If you're a returning subscriber, if you're new to this channel, I'm Andrew Gomanda and I strive to make geography simple. In this episode, we will be focusing on urban climate, which is part of microclimate. Remember, microclimate, this is the climate of relatively small areas, such as valleys and urban areas. Okay, so we did break down valley climate. Okay, so if you haven't watched that, it is in the climatology playlist, so please do. Valley climate and urban climate are both part of microclimate. Okay, so we did cover valley climate, as I said, and particularly under urban climate. Let's take a look at our CAPS document, which guides us. So under urban climate, we will be explaining the reasons for the differences between the climates that you'll find in rural areas and in urban areas. Why are there different climates in these areas? And we'll also break down the phenomenon of urban heat island, explain how it forms or why it forms, and describe the effects that it has towards humans, towards the environment. And we'll also take a look at the concept of pollution domes, explain its causes and its effects on humans and the environment. And lastly, we'll take a look at strategies that we can implement to try and reduce the impact that urban heat islands and pollution domes have on the environment and on humans. Okay, so without wasting any time, guys, let's get on to it. Right, so urban heat island, it's quite a simple concept, guys, because it's really when urban areas have higher temperatures than the surrounding rural areas. Okay, so it's as simple as that. Typically, you'd find out that the temperatures that urban areas have are typically higher than the temperatures that you're going to find in the surrounding rural areas, right? So we say that these urban areas form urban heat islands. Okay, so that is what an urban heat island. It is simply a warm pocket of air that you find in the urban area. Okay, so you're going to find warm air there. It's a warm pocket of air in the urban areas that is surrounded by relatively colder air masses in rural areas, in the surrounding rural areas, not too far. Okay, so that is simply what an urban heat island is, guys. Okay, now in order to understand why this happens, we first have to understand the morphology of the urban areas. Okay, so by morphology, guys, what I mean here is the makeup. How is it made up structurally? What is the proximity of the buildings, the design, the general design or structure of the buildings that you're going to find in urban areas? So you're going to find that in urban areas, particularly the CBD, the Central Business District, going to find out there are high-rise buildings. Okay, so buildings, skyscrapers, you have very tall buildings. That's what we mean there. So the height of buildings is high, right? And second of all, you're going to find out that particularly in the CBD, there is high building density. What do we mean by high building density? Well, we mean that in one particular area, you're going to find many buildings. Okay, so that's what we mean there by having high building density. It is dense. There's so many buildings in a small area. Okay, that's what we mean. Okay, so that's what we mean by high building density. Okay, there's many more factors that we will discuss that participate or contribute to urban areas having these or recording these high temperatures compared to the surrounding rural areas. Okay, remember that the surrounding rural areas, they do not have high-rise buildings, so there's no high-rise buildings there. And generally, you'll find out that buildings are less dense, so there's going to be low building density. So it's sparsely populated and there's less activity, there's less people, the buildings are far from each other. Okay, there's low building density. Okay, these are some of the things that we have to consider first before we get into urban heat island. Right, so in the exam, you typically find this diagram. Okay, so this diagram records temperature on the y-axis and on the x-axis has urban profile. Urban profile is simply the side view, guys. It's the side view of an urban area. Okay, we'll have a better drawn out urban profile when we're looking at land use zones in settlement geography, right? We are saying that urban areas generally have higher temperatures than the surrounding rural areas, and we call that an urban heat island. You're going to find out that sometimes these temperatures are represented by isotherms. Okay, so isotherms are simply these lines, guys, all of these lines, okay, that are in red, all of those are isotherms. Iso means the same, right? Isotherms, these are lines that join areas of the same temperature. Okay, so that's what we call isotherms. Okay, so the therm part, of course, should tell you that we are talking about temperature, right? So isotherms, do not confuse them with isobars. Okay, so isobars, of course, are lines that join areas of the same pressure, right? So they join areas that have the same pressure or atmospheric pressure. Those are isobars. You have isoheights. Okay, I'm just throwing these out, guys, just in case you come across these in the exam. So isoheights, these are lines that join areas with the same precipitation or rainfall, particularly rainfall. Let me rather write rainfall. I was saying that this phenomenon, which is urban heat island, can be represented by these isotherms. They use these isotherms, and these isotherms, of course, they have numbers associated with them. So you're going to find out as you move from the urban areas, moving towards the urban areas, the temperature increases. Okay, so it's increasing, and it's increasing by intervals of 5 degrees Celsius, right? So the highest recorded temperature, you'll find it in the urban area. So that means that we do have an urban heat island. So we'll discuss why this is the case. Why do you have high temperatures in urban areas, and why do you have low temperatures, okay, in rural areas? So there's many diagrams, guys, that they can use to depict the concept of urban heat island. You should see a question by its diagram before you even look at the questions, and be able to identify what concept is going to be questioned. And so having to be familiar with these diagrams, I think would really help you. So now we go ahead and ask the question, why are urban areas warmer than rural areas? Okay, so and you should also know, why are rural areas cooler than urban areas? If you do know why urban areas are warmer than rural areas, then you will know why rural areas are cooler than urban areas. It's actually the opposite. So I have some factors here. I have some points that I've written down that I've gotten from different sources, including the WCED lessons and self-study guides, MTG, so on and so on. You probably do have more points. So if you do have any more points, guys, that you can add on to this, please feel free to comment down below, and I shall comment on that. Okay. Why are urban areas warmer than rural areas? Well, first of all, the reason is that in urban areas, there's less vegetation. Okay, there's less green spaces. So the land use here is not particularly agriculture, but it is usually commercial activity, particularly in the CBD, and of course you have residential areas, so on and so on. But the point is that there's less vegetation, okay, in the city or in the urban areas, right? So you would ask, how is less vegetation warming up the urban area? So vegetation promotes evaporation via transpiration. Whoa, that's a lot of science there. So let's break that down. So when you have a lot of vegetation, what vegetation does is that it absorbs water via its roots. Okay, so it absorbs water via its roots like that. Okay, so that it can use it during its photosynthesis process. And whenever there's excess water or more than enough water that is in the plant, what the plant does is that it releases water, but in terms of water vapor, right? Okay, so it does release water in terms of water vapor. We call that transpiration. Okay, so that is simply the release of water in the form of vapor by plants through their structures that we call stomata, okay, which are like small holes that you find in the leaves. Okay, so but the point here is that plants release water vapor. Okay, so they are going to release water in the form of vapor. Okay, so now for all this process to occur, okay, if you're going to transform liquid water that is inside the plant into water vapor, you are going to have to absorb heat. Okay, you are going to have to absorb energy, right? So by absorbing energy, you are actually cooling down the city, or you are actually cooling down the air, right? So through the process of transpiration, which is sometimes called evapotranspiration, energy is absorbed from the surroundings. What do we mean by absorbing energy? You are absorbing the heat, or you're absorbing the warm air that is around. And so by absorbing energy, you are actually cooling down the surrounding air mass. Okay, so it has a cooling effect. So whenever there's evaporation, there's a cooling effect, guys. That's why there's fountains in urban areas. Fountains promote evaporation, and then evaporation lowers temperatures or has a cooling effect. Okay, so that's how that happens. That's how you explain that. Okay, so but you don't have to go down deep. I just want to ensure that you understand what you are talking about. So saying that vegetation promotes evaporation via transpiration. Okay, or you can say that vegetation promotes evapotranspiration, and because there is less vegetation here, there's going to be less evaporation, right? Because there's less vegetation, there's going to be less evaporation, and therefore there's going to be less cooling. Okay, so less evaporation, there's less cooling, because more evaporation promotes more cooling. And if there's less cooling, therefore temperatures will remain high. Having less vegetation or green spaces promotes less evaporation and hence less cooling. And therefore, temperatures still remain high because you're not cooling the air mass enough. So that's how we explain that, guys. And because in the rural areas, there's a lot of vegetation, there's dense vegetation in the rural areas. So because you have dense vegetation, you're going to promote more evaporation, right? And because there's more evaporation, there's going to be more cooling, and hence temperatures will remain low. Therefore, low temperatures. Okay, so you have to connect these when you are explaining, guys. That's how you get full marks. The second point is that buildings, not buildings. There we go. So buildings release heat. So buildings or industries or industrial buildings in urban areas release heat as part of their operations, particularly industries. Okay, so industries, they make, so you can, for an example, imagine a bakery. Okay, they are making bread, they are releasing that heat that is used to make bread. So you constantly release heat into the atmosphere, right? Into this confined area or small area. Of course, that heat that you are releasing will participate in increasing the temperature of the urban area, right? So industrial buildings such as bakeries, they release heat as part of their operations. Some buildings also release heat through the use of air conditioners. Okay, so air conditioners, what air conditioners do, guys, is that they take cooler air that is outside the building, bring it in, and release the hot air that is inside the building. Okay, so the hot air that is concentrated inside the building is going to escape into or remain in the urban area, right? So that also participates in heating up the air mass that is found in urban areas. Okay, so the use of air conditioners, those are your heat sources. Buildings are your heat sources. Industrial buildings are your heat sources. All of that heat is released into this atmosphere and contributes to the high temperatures that we see in urban areas. Okay, that's our second point. The third point is dark surfaces. Okay, so the color dark or black absorbs heat. So scientifically, it absorbs all electromagnetic radiation. But what's important here is that dark colored buildings absorb more heat than light colored buildings. Okay, so instead of reflecting it back, they are going to absorb the heat, and so the heat remains still within the city, within the urban area. Okay, we really have to be mindful in terms of which colors we use to paint our buildings. So you even observe this when you're wearing a black t-shirt. When it is hot, you're going to find out that you're going to heat up more because dark colors absorb more heat. Okay, so dark surfaces, dark buildings, dark paint absorbs heat. It does not reflect it back. So by reflecting it, you are sending it to wherever it came from. Okay, it bounces back. Fourth point here is that urban areas are warm because they have artificial materials. They use artificial materials. We use a lot of materials that are artificial. Artificial means man-made. We use a lot of man-made materials which absorb a lot of heat. So materials such as like tar, okay, concrete. You're going to find these in urban areas, not in rural areas. Rural areas have natural materials. Okay, we use natural materials there, and natural materials tend to not absorb a lot of heat. Okay, compared to artificial materials. Okay, so the materials that we use to build up buildings, to make roads, tar, for an example, they heat up much more faster than any natural surfaces. Okay, it should be natural there. Because we are using artificial materials which heat up much more faster, no wonder temperatures are high. Okay, so the use of artificial materials that we find in urban areas increases the temperature because they absorb a lot of heat, they heat up very fast, and hence, of course, the city will be warm as well. Right, so that's the fifth point. Then another point I have here is concentrated activity. What do we mean by that? So by concentrated activity, I'm referring to like human activity. Should have rather written human activity. Okay, so human activity such as many cars. You have many cars. Many cars enter the CBD, particularly the CBD. A lot of cars, because you have a lot of cars here in the CBD. Everyone is here. Now each car gives off its own heat. Okay, it gives off its own heat. Engines heat off. Engines give heat. Okay, and you have a lot of people, a lot of activity, many people in one place. Okay, I'm sure you do have an idea of that. When you are many in one room, it does get hot, right? So because there's many people, many cars that enter the urban area, this contributes to the high temperatures in the cities. Okay, because there's a lot of activity, a lot of people work in the CBD, and so you expect many people getting there. You expect a lot of cars. There's traffic congestion. Each car with its own heat comes into the city, and of course, all of that participates in the high temperatures that we see in the urban areas. Okay, right, I have more points here. For an example, there's the point of high-rise buildings. That's another point. So you can also say, because there's high-rise buildings, there's what we call multiple reflections between buildings. So what happens is that whenever heat is received, or whenever we receive insolation or incoming solar radiation, instead of bouncing back wherever it came from, it tends to bounce between the buildings. Okay, as you can see here, it bounces in between the buildings because there's high-rise buildings, and so the heat remains here in that ground level of the atmosphere because of these multiple reflections that are caused by high-rise buildings. If our buildings were much shorter, then this would not happen. Okay, so because of high-rise buildings, we see multiple reflection between buildings. And another point is the high building density. Remember, these two speak to the morphology or the structural design or structural morphology of the urban area, particularly the CBD. Now, the second point is the high building density. So because there's a lot of buildings, okay, as I've illustrated here on the top left, okay, because you have a lot of buildings there. Now you can think about air, okay? How do we remove that air when you have a lot of buildings? It's difficult for air to flow or flow out of these areas, okay? Because there's a lot of buildings, a lot of destructions, a lot of barriers, so as to say, which limit airflow. Okay, so high building density limits airflow, and hence this warm air remains in this urban area and cannot escape because of high building density. Okay, and you don't see high rise buildings, you don't see high building density in rural areas, and so there's easier airflow that you're going to find in rural areas. So air is able to flow easily because there's not a lot of buildings that are close together that limit air from flowing, right? And of course, there's no high rise buildings, and so you do not see multiple reflections between buildings. Okay, if you know why urban areas are warmer, then you should know why rural areas are cooler. Okay, it's directly the opposite. Okay, so I hope you can see that those are the causes of urban heat island, right? Now, I've also noticed that in the exams, they do not only ask about temperature, okay, but they also ask about rainfall. Okay, so talking about weather conditions, we can extend that to rainfall. We can extend that to relative humidity. Okay, so relative humidity speaks to the amount of moisture. Well, of course, in the urban areas, because there's less vegetation, there's going to be low relative humidity in urban areas. Remember, vegetation produces what? Water vapor. Water vapor is moisture. So, because there's not a lot of vegetation, therefore there's low relative humidity. Okay. What about wind speed? So, the wind speed in urban areas is low as well. Okay. Wind speed is low. Why? Because, well, there's high building density. It's very difficult for air to flow. Okay. So, there's low wind speed in urban areas because of the barriers, which are your buildings. Okay, it's very much difficult for air to flow freely. But what we do see though is that air tends to flow in between buildings. Okay, it is channeled in between these buildings, and so we do see turbulence in urban areas. But of course, the opposite is said for rural areas. There's higher relative humidity because, of course, there's so much more vegetation, which release a lot of moisture. So relative humidity is moisture, and wind speed is high because it's open. There's open space, and so air flows freely. Right, so what about rainfall? What about precipitation? What about clouds? So we see high amount of rainfall. So there's high rainfall in urban areas than in rural areas. Why? Because, well, in urban areas, first of all, there's warm air. What does warm air tend to do, guys? Because you have warm air tends to rise up. So warm air rises up, right? So it will rise up. You'll have warm air rising up. So if it rises up, it will leave an area of low pressure, right? It does not apply a lot of pressure on the ground, right? And so it invites air from the surrounding rural areas to come in, right, towards that low air. So in terms of pressure, the pressure is low in urban areas, but relatively higher in rural areas because rural areas are much more cooler, right? And so warm air with an X amount of moisture will rise up to the higher atmosphere and will condense, okay? Condense into clouds, and that will promote precipitation or rainfall. Okay, so with that, we call that convection. This is when the warm air, okay, so when air is warm, what it tends to do, it rises up, right? Because it is light. So it rises up, it cools down in the upper atmosphere, and it condenses into clouds, form clouds, right? So this is what we call convection, rising up of warm air. So because temperatures are high, a pocket of warm air develops, and warm air tends to rise up and condense, and therefore rainfall will result. Okay, so convection is one point there that contributes to the formation of rainfall in urban areas. And second of all, pollutants. So pollutants promote precipitation. How so? Okay, now let's think about this a bit. Well, let's say you have at your house, you have that particular kettle. Let's say on top you have a cupboard or whatever surface. It could be like a roof or whatever. When this water boils, what happens? What will happen? So when this water boils, remember this is warm and moist air, right? That is released by this kettle, right? So this warm, moist air will rise up, okay? So it will rise up as soon as it is released. It rises up, and now it gets in contact with that particular surface. It could be a cupboard, as I said, it could be any surface, guys, okay? Any surface. So it comes in contact with that surface. Now what happens? Okay, you find out that it forms what? Water droplets. That is what? That is condensation, right? That has occurred there. Because you have converted air, that was air, now it is water. Okay, so that is the process of condensation, transforming air into water, right? Now, that only occurred because it had a surface, because it was in contact with the surface. Okay, so that means warm air needs to be in contact with something. It could be a particle, it could be air, it could be a surface. Okay, so it cannot just condense, it needs to be in contact with a particle or particles. Now, because you have a lot of pollutants that are released in urban areas, remember you have industrial buildings that release pollutants each and every day. So pollutants now are released by urban areas. These pollutants now act as condensation nuclei. Condensation nuclei, these are the particles on which the warm, moist air will condense. Okay, so it will be in contact with these particles, the warm, moist air that is rising from the urban area. It gets in contact with pollutants. Once it gets in contact with these pollutants, now it can condense and form these clouds. Okay, so now these clouds form because of the pollutants. These air particles, the warm air particles, they condensed onto these, and of course rainfall will follow. So these pollutants give or provide the surface on which to condense, right? These condensation nuclei are also called hygroscopic nuclei, just in case you come across that. Hygroscopic nuclei, and these promote condensation. So whenever you have a lot of pollutants, you are indeed going to promote rainfall, right? Precipitation. Okay, so now whenever this happens, guys, you are actually going to promote acid rainfall. Okay, so because now these warm air particles have condensed onto pollutants, rain will be acidic. Okay, and acid rainfall can affect a lot of buildings. Okay, it can erode buildings, it can change soil pH, so on and so on, right? So we've answered why urban areas are warmer and why urban areas are more rainy than rural areas. Okay, so in rural areas, of course, because you have less warm air, you are not going to promote convection, and hence warm air will not rise, and hence you are not going to form clouds through condensation. And because you do not produce pollutants in rural areas, you are not going to promote rainfall. Okay, so you have to think of this in both ways, right? What about the effects of urban heat islands? Okay, first of all, urban heat island causes exaggerated heat stress. It can even cause death as well during heat waves. So there are periods where there will be very high temperatures that are recorded by the country, and you're going to find out that temperatures are much more exacerbated or exaggerated in urban areas, and so that causes a lot of heat stress among us, and it can actually cause death, right? So during heat waves, urban areas are even worse. Okay, so that is one effect of urban heat island. Another one is increased costs because of increased water use. Okay, so because it is very hot, very warm, very hot in the urban areas, you are going to consume a lot of water, you're going to use a lot of water. And so, of course, that will cost them because water is a resource that is paid for. And there's an increase in evaporation rate as well. So, evaporation rate also reduces the amount of water that is available, right? So, this is a wastage of water because of high temperatures that are recorded. Okay, so there should have been acidic rainfall here as well. Okay, so acidic rain, which damages buildings, or the paint of buildings or statues, and of course affects vegetation because it changes the pH of the soil, right? So these are some of the effects of urban heat islands. So if you have any more effects of urban heat island that you can provide, please do so, guys, in the comments. I would really much appreciate that. Okay. So what do we do? What can we do to reduce this impact or minimize the impact of urban heat island? So first of all, because we know that dark surfaces absorb more heat, what we can do is we can paint roofs or buildings with light colors to prevent the absorption of heat. Okay, we rather promote the reflection of heat. Okay, reflecting heat, remember, that means that radiation bounces off the surface and so it is not absorbed, right? So we can paint buildings with light colors and promote more reflection than absorption. Second of all, we can develop rooftop gardens to promote evaporative cooling. Okay, we need a lot of gardens, guys, and a lot of roofs are usually painted with black or dark colors. So if we could develop rooftop gardens or have gardens on top of the roofs, then that would mean promoting evaporative cooling. That would help cool down the city. We could decrease building density by decentralizing. Decentralizing means moving businesses or organizations or buildings away from the city center. Okay, because there's a lot of activities in the city center. Everyone is here. It is concentrated in the city center. So in order to reduce that amount of activity and improve airflow, guys, improve airflow, we can just implement decentralization. Move buildings. Buildings do not have to be in the city center. Move them to other areas where they can also be profitable. Okay, so this will indeed help decrease the temperature by improving airflow, right? Because there's not going to be a lot of buildings that are concentrated in one small area. We can restrict the height of buildings. So whenever a town is being developed, what we can do, we can change policies, laws, guys. We can improve our laws for the benefit of urban areas. So by restricting the height of buildings, we would be preventing having high-rise buildings. Remember, high-rise buildings promote multiple reflections in between buildings. So if we have much shorter buildings, then we do not have that process occurring and hence increasing temperature. We can implement zoning, okay, for green areas. So that should be for space, green areas, such as parks in cities. So zoning, this is a process of lawfully restricting any other land use. Okay, so if I'm saying that this zone, this is only for parks or this is a green zone, then no one is allowed to build any building or build any facility or anything else other than a park. So this is protected by law. So zoning means that it is unlawful to build anything here or building or a business or whatsoever. This is only restricted for parks. Okay, so if you can implement zoning for green areas such as parks and cities, that would help, of course, cool down the city via evaporative cooling. Instead of everyone entering the urban area with their own car or own vehicle, what we can do is that we can promote the use of public transport. Okay, and this public transport must be sustainable, guys. It must also use alternative energy. We can use eco-friendly or natural building materials. There's much more variety of materials that are strong enough that we can use to build our buildings instead of tar and concrete and all of these materials that retain heat, that absorb a lot of heat. Okay, so these are some of the strategies to reduce urban heat island. And I hope you can reason, guys. Very important to give reasons why, how. Okay, you have to be able to explain that. Okay, so if you can explain it, then you do understand it, right? So this is the concept of urban heat island. Now I'm going to head on to pollution dome. So pollution dome, this is the last concept that we have under city climate, right? So a pollution dome, guys, it's simply a trapped mass of polluted air over a city. Okay, so it's MS that is filled with a lot of pollutants in an urban area, right? So we clearly see, because the urban area produces a lot of pollutants, we see different profiles of these pollution domes during the day and also during the night, right? So we see that the pollution dome during the day has this mushroom shape. Okay, it is much more elevated. It has this vertical dimension. Okay, so it is much more higher up. It is much more expanded. It has this vertical dimension. And the reason is because, remember, during the day, it is hot, right? And so warm air, what does warm air tend to do? Warm air tends to rise up. Okay, so it expands this polluted air mass that we found over a city, such that you're going to find out there is colder air that is in the upper atmosphere. Okay, so the colder air, going to find it higher up in the atmosphere, because this pocket of air expanded or expands, and so it pushes that inversion layer upper in the atmosphere, right? Okay, so we see that heating causes air to expand, and inversion layer is higher up during the day. You have to know the characteristics of the pollution dome during the day and during the night. Okay, so because there's rising warm air, it expands this pollution dome. It gives it that vertical dimension, it elevates it, it gives it that mushroom shape. So now the pollution is much more dispersed. It is much more easier to send those pollutants away. Okay, they can be able to escape from the ground, from the city, right? Because now air is rising up. Okay, we talked about this phenomenon of warm air having to escape with pollutants during anabatic and katabatic winds, okay, in the valley climate, right? So that is the shape that it conveys during the day. And then during the night, now because during the night it is cold, you have cool air that pushes down, right? So cool air is dense, right? And so it's going to be heavy and it's going to want to sink down, and it will push this pollution dome such that it is much more closer to the ground, much more closer to the CBD or the urban area. Okay, so it does no longer have that elevated dimension or that vertical dimension. Now it looks like a dome. It is much more concentric and much more closer to the surface. Okay, so because it is cool, and we usually see this even during winter. So because during winter it is cold, cold air tends to sink down. So we find that pollution dome becomes small. It becomes this dome. It becomes much closer to the city because it is pushed by that inversion layer or by that air mass of cold air down towards the surface. Now let's take a look at the causes of pollution domes. Okay, so this must be simple because, well, pollution, what produces pollution? Well, industries. A lot of industries produce a lot of pollutants during their industrial processes to produce whatever products that they are producing. They use a lot of chemicals, and pollutants are byproducts, or they are some of the products that are released, but not as major products, not as the main products, but they are released because they are part of the process. A lot of industries produce a lot of carbon dioxide. We see a lot of carbon monoxide. We see nitrogen dioxide, so on and so on. There's a lot more pollutants that are produced by industries. We also see this in car exhaust fumes. Cars produce pollutants. While moving, they are burning the fuel to produce a lot of pollutants. Okay, so a lot of cars, and you see a lot of cars, a lot of vehicles in the CBD. And so a lot, because there's a lot of traffic congestion, there's a lot of cars that enter the city, a lot of pollution is produced there, a lot of pollutants are produced. Okay, through the burning of fossil fuels. So for an example, fires. Okay, you have fires where we are burning trees. There could be during the industrial processes. Okay, so it could be many different types of scenarios, but the main point is that we burn fossil fuels which release these pollutants into the atmosphere. There's the inversions that trap pollution. So these inversions, as we see during the night, this inversion pushes down these pollutants towards the people, towards the lower atmosphere, and hence this trapped air mass of polluted air is found much more closer towards the people because of these inversions. Okay, so these are some of the causes of pollution domes. Let me know if there's any more sources of pollution or pollutants that you know of in the comments, guys. And there's also, of course, the effects of pollution domes. First of all, the human impact of pollution domes is that they cause respiratory illnesses like asthmatic attacks. These can lead to lung infections, so on and so on. These are some of the respiratory illnesses or the health implications that pollution domes have. They can increase precipitation as well. Okay, we talked about pollutants having to act as a condensation nuclei or as hygroscopic nuclei on which warm moist air condenses and forms clouds. And so these act as that condensation nuclei and promote the condensation process and therefore increase precipitation. Pollutants participate to global climate change. Okay, so remember, we are producing pollutants here. Some of them are greenhouse gases, which lead to global warming, participate in global warming, and therefore promote climate change. Okay, so globally participate in the global climate change. So we have to really change our ways if we are going to beat this. There's smog. Okay, remember smog. This is smoke or pollutants, and fog, right? So that makes smog. Okay, so when there's fog that has a lot of pollutants, it's much more difficult to see. It reduces visibility, and of course, because it has a lot of pollutants, it causes respiratory illnesses. Okay, reduces visibility, and of course, this leads to traffic accidents and fatalities. So these are the effects that pollution domes have. And as I said, guys, these are some of them. If you are aware of many more, please drop them down in the comments below. This would help everyone. Okay. Now, what can we do to minimize the impact of pollution domes? Well, first of all, we can control the amount of pollutants released from factories or industrial buildings by issuing fines. So government has to really regulate the amount or control the amount of pollutants that are released by these factories. Okay, they have to be fined. They have to be charged. If we could charge them, then they would, of course, release less pollutants, because every business has a goal of ensuring that it generates profit each and every time. And so if we would charge them for releasing a lot of pollutants, then these would help control the amount of pollutants, okay, control the amount of pollution. And technology could help a lot, advanced technology that would help regulate the amount or tell us, is this factory or which factory produces a lot of pollutants each and every day. Okay, so we can issue fines each and every day, each and every time they release more than accepted pollutants. We can use public transport, okay, because if we can use public transport, then we are actually saving the world from a possibly high amount of pollution if everyone had their own car. So the use of public transport reduces the amount of pollution. We can invest in energy saving alternatives, okay, for an example, solar panels, okay, wind energy, right? So if we could invest in these, we would avoid the reliance that we have on fossil fuels, which participate in pollution. We can plant roof gardens to reduce pollutants. What do we mean by that? Well, plants take that carbon dioxide, which is a pollutant. They take it in. So that's why we call them carbon sinks, because they take in the carbon dioxide and they produce what? Oxygen, right? During their photosynthesis process. So if we would plant a lot of roof gardens, each building having its own roof garden, then that would promote the absorption of carbon dioxide by trees, and hence there will be less carbon dioxide in the air, right? So that would help minimize the impact of pollution domes, right? So I hope that was made simple, guys. I hope you now have a better understanding of city climates, urban climate, and I hope this was very helpful, and I pray it comes in handy when you are writing your assessments. Now, that is all I have for today, guys. Thank you so much for tuning in. Please like, please comment, please share and subscribe for more and more and more videos. See you in the next episode.